Hey guys, welcome to my YouTube channel and to my next episode. In this episode I want to talk to you about the Big Bang chronology, which explains what happened after the Big Bang. The Big Bang can be explained in 5 stages: the very early universe, the early universe, dark ages and formation of the structures, the universe which appears today, and the ultimate fate of the universe. The very early universe. No one knows what happens at t equals to 0, but physicists can go up to 10 to the minus of 43 seconds after the Big Bang. The temperature of the cosmic fog was about 10 to the power of 32 Kelvin. This stage is known as the Planck epoch. In this, the universe was in a Planck state, meaning that the current theories of the gravity and other physical theories doesn't work. During that time, quantum effects dominated the universe. The Planck epoch was followed by Grand Unification epoch. At around less than 10 to the power of negative 36 seconds, three forces, electromagnetic force, strong and weak nuclear forces, were still unified. At that time, it can be said that the Grand Unified Theory, which is otherwise called GUT, may be able to describe the state of the universe. The Grand Unification epoch was then followed by Inflationary epoch. At around 10 to the minus 32 seconds, the universe expanded by the order of 10 to the power of 28 times the size as compared to 10 to the minus 36 seconds. It also went supercooling mode from 10 to the power of 28 Kelvin to 10 to the power of 22 Kelvin. At this time, strong nuclear force got separated from electroweak force, which is the weak and electromagnetic force. The universe was radiation dominated with massless relativistic components such as photons and the neutrinos. At around 10 to the minus 12 seconds, the electroweak epoch ended. The average interactions of the particles were high. It is at high energy such that the Higgs field is off, meaning that all the particles, including fermions, were massless. Radiations emitted a large number of particles such as W, Z, and Higgs bosons. As the universe cooled and expanded, the W and Z bosons decayed very quickly and reached to the W and Z bosons that we observe in particle accelerators right now. The radius of the observable universe was around 300 light seconds at this time. Then it's followed by quark epoch. At this time, the universe kept on cooling and the energy of the particles also became as low as Higgs field then turned on. The electroweak force then got converted to the massive Higgs, and weak force then carried massive W plus, W minus and Z bosons, and the electromagnetic force then carried massless photons. The fermions also became massive as the energy was too high to form hadrons, so quarks formed quarks gluon plasma instead. The quark epoch was then followed by hadron epoch. At around 10 to the minus 5 second to 1 second, the energy was low as it favored hadron formation like baryon and mesons. The baryon asymmetry came into existence. At the end of the epoch, stable baryons like neutron and proton remained. Due to high density of leptons, they went through a rapid exchange under the action of weak nuclear force. From 1 second to 10 seconds, neutrinos then interacted with baryonic matter, forming cosmic neutrino background. The universe was around 10 light years at that time, but the energy was too high for entire leptons and leptons to form out of photons. Then it is followed by Big Bang nucleosynthesis. At this time, protons and neutrons were then combined into primordial atomic nuclei of hydrogen and helium-4. Other isotopes of hydrogen and lithium-7 were also formed in small traces. At this time, the observable universe was around 300 light years in radius, but the energy was still too high, which was more dominated by electromagnetic radiations. Then is followed by photon epoch. At around 10 seconds to 370,000 years, the universe became a bath of plasma of nuclei, electrons and photons. At this time, the energy was low such that the pair production is not possible, but high for electrons to bind them with nuclei to form atoms. Then it is followed by recombination process. At around 18 to 370,000 years, the first neutral atoms were formed. The universe then became transparent as the photons are no longer in a thermal equilibrium. At this time, CMB, cosmic microwave background, originates from the leftover photons. The observable universe is then around 42 million light years across. If you want to know more about cosmic microwave background, then I have put the links in the description below, so check it out. Then is followed by the dark ages. As the CMB redshifted into lower wavelengths such as the infrared wavelengths, and the hydrogen emitting radio waves were the only source of the photons at that time, the universe was then dark until the first stars were formed. Then gradually the first stars and galaxies were formed. From about 300 million years after the Big Bang, the earliest known galaxies were thought to be formed, followed by modern galaxies about 1 billion years to 10 billion years after the Big Bang. At present time, CMB is the farthest observable photons that comes from a sphere of radius of 46 billion light years, that what we call the radius of the observable universe. And the universe is about 13.8 billion years old. But the theory faces some limitations to explain the dark kinds of stuffs that fills up the entire universe, and wonders like why there is something out of nothing. Therefore, in search of this, countless researchers are working day and night to understand more about the universe which we live. It's always a tug of war between the God which created the universe and the followers trying to perceive his course. Well, sounds interesting, right? Well, not easy as we might think.